People for a very long time have tried to put a value for the steepness of a line. Lines are found all over in the real world, from ski slopes to firefighters with ladders to broken down trees and the angle they're lying at. They're all over the place. And there was really a need to quantify that steepness. There needed to be a name and a value, a way we could describe it in everyday or in a mathematical way in everyday language. The name that was given was slope. It's possible and often easier to graph lines using this idea of slope and a point as opposed to a table. Also, it's not difficult to write an equation for a line from finding the slope and a point from the graph. So slope makes life a little bit easier when working with equations of lines. But first, let's define slope, and then we can use that idea to help us in other ways. The slope of a line is a number that describes both the direction and the steepness of a line. The letter m is typically used as the variable for slope. So whenever you see m in an equation, you should think slope. The slope of a line can have four types of direction. You can have positive, like this blue line on our coordinate plane, rising from left to right. It's like we're walking up a mountain. Negative, falling from left to right, like this black line on the coordinate plane, walking down a mountain. A zero slope, which is horizontal, like the green line, think horizontal for the horizon. And then an undefined slope, which is a vertical, like this orange line on the coordinate plane. To measure the steepness of a line, we are going to use the ratio rise over run, because again, that is helping us with the direction and the steepness of that line. The rise is the change in the value of the y coordinate, while the run is the change in the value of the x coordinate. So we have a rise from one point and a run to the other point. The symbol for change is the Greek letter delta, which is this little triangle, which just means change in. So the slope is equal to the change in y divided by the change in x, or using the little triangle y divided by triangle x, meaning delta y over delta x. And in order to find a change, we want to use a subtraction. We want to subtract the values to find their difference, that change. So the change in y is y2 minus y1 from the first y value or the second y value back to the first, and then the change in x is the second x value to the first x value. So that's a very important formula for slope that we can generalize to any point on the line. So here is one specific case. So we have 2 points on the line. We have 2, 4. There's our x1 and y1. And we have 8, 11. There's our x2 and y2. So if we try to find the slope, the rise is the difference between the y values. We have from 4 to 11. So delta y is 11 minus 4, which is 7. And the run is the change in the x values from 2 to 8. So delta x is 8 minus 2, which is 6. Therefore, the slope, delta y over delta x, we now have is 7 over 6. So the slope of this line is 7 over 6. Any points on the line can be used to calculate its slope, since the slope of a line is the same everywhere. The values of delta y and delta x may be different for other points, but their ratio will always be the same, so you could always reduce. And we can check that with the red and green triangles shown here. So here, the green triangle. So we can see here with the green line, or the green delta y and delta x, that if we use the points, we're going from the point 0, 0, to the point, this point here, 6, 10. So we have our x1, y1, and our x2, y2. So we have 10 minus 0 as y2 minus y1, and 6 minus 0 as x2 minus x1, which simplifies to 10 over 6 and reduces to a slope of 5 over 3. So that is the slope from the delta y and delta x of the green from those 2 points. Now let's look at the delta y and delta x from the red. From the point 5, 8 to the point 8, 13. So we have, again, x1 and y1 and x2 and y2. So we have 13 minus 8 as y2 minus y1 and 8 minus 5 as x2 minus x1, which simplifies to 5/3, which you can see is the same exact slope as the 2 points, which was the green delta y and delta x. So no matter which 2 points we used, we still got the same slope as 5/3. Slope is also referred to as a constant rate of change. Here is an application of slope where that would apply. A road might rise 1 foot for every 10 feet of horizontal distance. So 1 foot is your change in y, and 10 feet horizontal is your change in x. That ratio, 1/10, which is also called the slope, is now the measure of the steepness of the hill. Now, this is a real-life application because engineers call this use of slope grade and measure the grade with percentages. So the grade of the road above is 10% because it's 1/10 as the slope. Horizontal and vertical lines have special slopes. A horizontal line has a slope of 0, and a vertical line has an undefined slope. Let's see what makes these slopes so special. So 2 points on the horizontal line are 0, 4, and 3, 4. If we look at the graph, the delta y is 0 and the delta x is 3. Basically, there's no change in y. You still have a y value of 4 in each of your points. So m, delta y over delta x, is 0 divided by 3, which simplifies to 0. So the slope of any horizontal line is 0. Very similarly, 2 points on the vertical line we have here are 7, 2, and 7, 0. If we look at the graph, the delta y is 2, the change in y, and the change in x, delta x, is 0. Again, there's no left or right, there's no horizontal change. You have the same x value of 7 in both points. Both of the points have an x value of 7. So if we look at that within the formula, m equals delta y over delta x. So 2/0, well, that's undefined because you cannot divide by 0. So the slope of any vertical line is 0. So thinking about whether it's positive, negative, 0, or undefined, there's so many different ways of thinking about slope, defining it, and using it when looking at your different lines on the coordinate plane and the different equations you can make.